The stack is used to store data when the most recently used data is also the first needed. The stack performs two main functions: push, which puts data on top of the stack, and pop, which takes the top data off the stack. When a function exits the stack, it is automatically reclaimed, which is convenient for a programmer if the data is no longer required. However, if the data needs to be kept, then data from the stack would have to be copied before the function exits. This means the stack is best for temporary data, such as our local variables that we use in our Java applications. So let's say some code calls the method m1, which stores a variable x, and then calls the method m2. When this executes, a frame will be created on the stack, made up of m1 and its variable x. Then as we move to m2, another frame will be created on the stack on top of m1, made up of m2 and its variables b and c. Then, when the program finishes and the flow of control moves back to the calling method, first the frame m2 will be flushed from the stack. Then when the flow of control moves back to the original calling method, most likely the main method, then the frame m1 will be flushed, and the program moves back to its original starting point. The heap, also known as free store or dynamic memory, is a large pool of memory used to store data that needs a block of a sufficient size. To satisfy memory requests, portions of the heap are allocated to current data that needs to be stored. This then means parts of the heap are in use, while others remain unused and available for future allocations. In Java, the heap is used to allocate memory to objects and classes during the runtime of the Java virtual machine. There are often two portions of the heap in Java, the nursery and the old space. The nursery is reserved for allocation of new objects, and when that gets full, garbage collection is run and objects are moved from the nursery to the old space, thus freeing space in the nursery for new objects. Then when the old space is full, then garbage is collected there. So as you can see, I've taken the original example that we used using m1 and m2, and I've added a method m3. Now m3 creates an object from the account 2, which has two instant variables p and q. So when this executes, you'll get a frame as before from m1, a frame from m2, and then obviously we get a new frame on top of the stack for m3. Which will also create the reference variable. Then the object will be created on the heap, and the assignment operator will make a reference from the reference variable to the object on the heap. Then when the program is finished and the flow of control moves back to the calling method, the frame m3 will be flushed, and then the object will be available for garbage collection. Then, as before, m2 will be flushed, and m1 will be flushed, and the program will return to its original state. A stack overflow occurs when the program attempts to use more space than is available on the call stack. The call stack is made up of different factors, including the programming language and the amount of available memory. And if the program tries to use more memory than the call stack has, then it is said to overflow, typically resulting in a crash. So let's take a quick look at an example of Stack Overflow. So I've got a method which calls itself, and then a main method which creates an object and then calls my recursive method. And when we run this, we just get a constant error which just keeps going, never-ending error of a Stack Overflow example, because it keeps calling itself and there's not enough stack for it. As we said in the heap example, when all references to an object are lost, that object no longer contributes to the program, and this object is referred to as garbage, as it has no useful purpose. When it is considered garbage, that object is marked as such. Java performs automatic garbage collection. This means occasionally the Java environment executes a method which collects all the objects marked, and returns the memory to the system for future use. What makes the garbage collection in Java one of the best aspects of the programming language is that all of this collection is done automatically. Unlike programming languages like C, in which allocating and deallocating memory is a manual process.